Okay, so let's do some examples. Example um, find Laurent series for cosine z over z to the 3 at z equals 0. So, um, yeah, so is that, first of all, is that even possible? It's possible. The theorem applies because, this function is analytic. It is a ratio of analytic functions, and, you know, z to the 3, the denominator is only 0 at 0. Okay, so we're good. Theorem applies. So let's get straight to the. So let's find the coefficient. So we have 1 over 2 pi I. You have a contour around, you know, 0. So z to the k plus 1, and then f, which is cosine z over z to the 3. Okay. Uh, so cosine z, and then 3 plus k plus 1. All right. So before we move on, we have to answer some questions. When is this even not 0? If 3 plus k plus 1 is, you know, less or equal than 0, then by Cauchy-Groschat, the integral is 0 because it's analytic. Okay, so all we care about is, so we care about, you know, 3 plus k plus 1 strictly bigger than 0, or if you like, 3 plus k non-negative. All right. Uh, so here I can just use the CIFT, Cauchy integral for derivative. Yeah, so where's my formula? Yeah. So this is 3 plus k factorial, and then you have to take the derivative 3 plus k times, right, of cosine, and then evaluate at 0. Good. All right. So, sine of 0 is 0, so not every term survives. So this is equal to 0 when, what is it? When 3 plus k is odd. In other words, when k is even. And it survives to give you minus 1 to the k plus 3 over 2 when the opposite, k is odd. Okay, so this minus 1 is because, if you take derivative of cosine, you get minus sign. So that's how you pick up this minus. All right, so we found our coefficient. Let me write down the series. the Laurent series is the following sum. K plus 3 has to be strictly positive, and K has to be, well, let's do one step at a time. So uh, C minus 0. Now, when K is even, you get 0. So you're left with K being odd. Okay, and we found the coefficient. So that was so K plus 3, 3 plus K factorial minus 1 to the K plus 3 over 2. And is it C to the K. Okay, but we can write this a little bit more clean. So what's a cleaner form? You can do a change of variables. So this is minus 1 to the m over 2, m factorial, z minus m minus 3. But anyhow, so I will, yeah, let's write down the first few terms. So if you put m equal to 0, you get z cubed. If you put m equal to 2, which is the next even number, so 0, 2, what is it? Minus 1, 2 factorial, and then 1 over z. And then, yeah, then it becomes constant. Anyhow, so let me scroll down. This guy, this um, this guy is analytic, and this guy will be the principal part. Okay, so that's that. I should say that a faster way, so uh, possibly quicker way, you write down the Taylor expansion for cosine, which is the following. And then you just divide both sides by z to the 3, right? And then you bring it in and you get your minus 3. So let me just leave it like this and then divide both sides. All right, anyhow, uh, let's do another example. Okay, find the Laurent series of uh, 1 over z minus 3 in z and 3. So yeah, they want you to find it around 0. Um, anyhow, so yes. But anyhow, but the point is, yeah, here it goes up to 3, so we're not worried about the other pole. Um, so F, you know, um, the the f of z is analytic because c equal to 3 is not inside the the puncture neighborhood. So this is a nice example to show you that you can have poles at the boundary, okay? But you cannot have them inside. So if it was 4, say, then you cannot do it. And I will do an example right after. All right, anyhow, so let's apply the theorem. Laurent theorem. So this is 2 pi I, um, what is it? Z minus Z3 over Z to the K plus 1. Okay, so that's your guy. Uh, Let me write it a little bit differently. So Z1 plus K plus 1. So as before, you have to figure out when is the 0. So this is when the exponent K plus 2 is uh, strict when it's less or equal than 0. Okay, so all these terms will disappear by Cauchy Goursat. That's fine. Okay, so assume, what did I assume? Yeah, K plus 1 is less or, let me write like this, strictly positive, so K plus 1 non-negative. Okay, good. So same business, by Cauchy integral formula for derivatives, I give you the following: 1 plus k factorial, and then take 1k derivative of z to the minus 3 and evaluate at z equals 0. Is that okay? All right, so I computed that, and that gives you minus 1 to the k plus 1. Yep, 1 plus k factorial and minus 3 to the k plus 2. Good. All right. So the series is the following. K has to start from, we said, plus 1. Uh, yeah, K, so from minus 1. Um, yeah, so AK and then Z to the K. Uh, right. The K cancel out. So you just have minus 1. And then 3 to the K plus 2. Z to the K. And yeah, let me write a few terms. So first guy is minus 1/3 Z, and the rest is analytic. So this is analytic, we don't care about it. And this one is the principal part. And you will see in the next section why we really need um, the coefficients of 1 over z. But okay, that's a separate story. All right,